Hello students, welcome to Educate. In the last video, we have completed the transition metals. Now we will start from inner transition elements or inner transition metals. Why that is called inner transition metals? Because here in these elements, the last electron enters in inner penultimate matrix. That's why these elements are called inner transition elements. In case of transition metals, the last electron were entering into the penultimate set. But in these elements, the last electron will enter in inner penultimate cells. That's why these elements are called inner transition elements. The inner transition elements include lanthanoids and the actinoids. Inner transition elements includes lanthanoids and the actinoids. Let's see here about the lanthanoids. Why they are called lanthanoids? Lanthanoids are called because the first element of this group is lanthanum. That's why they are called lanthanoids. And in case of actinoids, the first element will be actinoids. That will be called actinoids because the first element will be actinium. Now let's see here electronic configuration in the periodic table. What will be their periodic properties? First one is electronic configuration. So electronic configuration of lanthanoids is complicated. There is no regularity in the electronic configuration because the 4F and 5D that have similar energy. That's why sometimes electron enters in 4F and sometimes in 5D. But even though in the examination, particularly for IIT main examination, writing the electronic configuration sometimes asked, and in 12th board examination also, question has been asked about the electronic configuration of a particular lanthanoid group. So here this one is the name, and in the mugging of this name, I cannot do anything, guys. You will have to mug up. Like lanthanum, cerium, this one you have to mug up only. But I am telling you about the electronic configuration, how to write. Okay. So firstly here atomic number 157, 5T. This one is actually there is no any electron present in 4F orbital. Then after here one electron goes in 4F, and now in the next element the electron from 5D will also enter there. Atomic number has been increased, so 4F2 and one electron from here also jump. So that's why 4F3, and that will continue till the 4F will not become half filled. 4F became half filled, that means 4F7 came, and after that again electron will enter in 5D. Then after 4F8 and one electron also entered there, so that's why 4F9 and 4F9, and then after electron will start entering there, 4F14 and then after 5D1. So that was the trick by which how you could write the electronic configuration of element when you will know the name of the element. The name of the elements you will have to mug up. In the name I cannot do anything. Okay, here now let's see general characteristic. One of the general characteristic is here, these lanthanoids are silvery white soft metals. Okay, this one here, and their hardness increases on increasing the atomic number. Okay, first one, this one you will have to keep in the mind that they are silvery white and their hardness, silvery white soft metals, and their hardness increases, and samarium is very hard. Then after characteristic you study by yourself. These are mostly information based. So when you will study this one, you will understand very easily. And like no need to mug up what will the first ionization enthalpy of lanthanoids and this one, no need to mug up. Okay, one is here about the characteristic here. So usually the lanthanoids show +2 and +3 oxidation state. Okay, but most frequently the lanthanoids show +3 oxidation state. Lanthanoids usually shows +3 oxidation state. Okay, now one thing also I have left, that is size. Watch out about the size. That means here lanthanoid contraction. And what is the meaning of lanthanoid contraction? If you will study this graph carefully, sincerely, when you will study this graph, then you will predict what's the meaning of lanthanoid contraction. So, and how significant is lanthanoid contraction? Is how much significant? The regularity in the atomic size we frequently shown in +3 oxidation state. The lanthanoid shows periodic trend in their atomic size in +3 oxidation state, and that's on increasing the atomic number. The ionic size decreases vigorously. You may compare about this one, how much decrement in the atomic size, this ionic size here, how much there be difference, and that is due to lanthanoid contraction. General term is lanthanoid contraction. Means what is here, on increasing the atomic number, there be tremendous fall in the size of the lanthanoids, and that is called lanthanoid contraction. That phenomena is called lanthanoid contraction. Let's see here general characteristic we discussed. That's so usually +3 oxidation state. +3 oxidation state. So chemical properties of the lanthanoids will be also so that the lanthanoids will show +3 oxidation state. Like that, when lanthanoids react with nitrogen, so lanthanoids show the oxidation number of +3, nitrogen here -3. So that's why +3 and -3. So that's why one lanthanoid will combine with one nitrogen, and that's why that form LIN, that compound. Now let's see for when they react with carbon. So lanthanoids show the oxidation state of +3, and carbon show the oxidation state of +4. So here what happened, LNC has that I tell you later on. Firstly, now when with water, so here it's a base, so lanthanoids displace the hydrogen, so that's why LNOH whole thrice, because lanthanoids +3 oxidation state, hydroxide -1 oxidation state. So 3 hydroxide combined with 1 lanthanoid, and that's why form LNOH whole thrice. Same here halogen. Halogen shows +1 oxidation state, lanthanoids +3 oxidation state. Halogen -1. So that's why LiX3. Okay. Now with acids, it's displaced hydrogen. When combined with the oxygen, same here, lanthanoid +3 oxidation state, oxygen -2. So to balance them, the charge here 2 will multiply, here 3 will multiply. So 2 lanthanoids will combine with 3 oxygen and form Ln2O3 as the compound. Same here, Ln2S3 the compound. That is okay. Now let's see. Another one is actinoids. About the actinoids, first one, electronic configuration, frequently not asked. Here electronic configuration frequently not asked, but I tell you here. Actinoids, all the elements of the actinoids are radioactive, and that's why a detailed study of the actinoids is not available. Due to its radioactive nature, their half-life period will be also less, and that's why that means of the higher members, their half-life period are also less. So due to their radioactive nature, the lots of information about the actinoids is not available. Now electronic configuration, let's see here what is here. 6s1, 7s2 here. Firstly, as the actinoids here increases, then after 4f come and 2 electron also So 4f comes, one electron from 3d goes here. Then after in d electron there will be same, and in f increases. Then after in f increases till here, and then after 6d. So by this one, when you will compare, by the comparison when you will do, when you will study by this one by comparing, then very easily you could write the electronic configuration of actinoids also. So firstly you will have to mock up the name. Ionic electronic configuration, that is also here highly irregular, about which we have discussed. Ionic size, here also actinoids contraction, and actinoid contraction is more vigorous than that of lanthanoid contraction, because in actinoids there will be no difference in the energy of 5F and 6D. So actinoid contraction is more vigorous than that of lanthanoid contraction. Oxidation number, so generally so +3 oxidation state. Okay, you know, occasionally +4, +5, +6 also shows. That is here. General characteristic of comparison with lanthanoids here. Actinoids are silvery in appearance, that's also silvery appearance. And then after is, so you study by them only here, not so much silvery in appearance, like lanthanoids is also silvery in appearance. Okay. Actinoid contraction are more vigorous than that of lanthanoid contraction. We have already discussed here. And lots of studies, there is not a number of information available for the actinoids due to their radioactive nature. Now let's see here. Name a member of the lanthanoid series which is well known to exhibit +4 oxidation state. That's the informaticism. You will have to mug up sodium. Okay. Why actinoid contraction? I have discussed why actinoid contraction, because the 5f orbital and 6d orbitals, the difference in the energy of 5f and 6d is not so much. That's why actinoid contraction is more vigorous than that of lanthanoid contraction. Some application of D and F block elements. So this one here, that will be important for you for the competitive examination. Importance here. Alloy is this one. Okay, this one more important. Ziegler catalyst. The Ziegler catalyst is the mixture of titanium tetrachloride and aluminum trimethyl. This one you will have to just watch out here. Just read them. Okay, this one is important. It's all for the D and F block elements, and these questions were very easy. Here, when we go through the exercise, questions of exercise, you will very well write them. I am not telling how to write that. Better will be that you write the answer and then after contact. You write the answer of these questions, because here these are explanatory based, and if I tell you how to write, that will be not better. Better will be you write, answer the question, these questions, and consult the Educate channel, and definitely I shall check you and inform that what's the mistake usually students are doing. Based on that, I shall make the separate video how to write the answer of these questions. Okay, so for any help you consult the YouTube channel Educate. It's all for this class. Thank you, Team Educate.